Today we are going to talk about one more technique that can be used for deploying the models. And today's technique is very interesting, and we will basically try and understand why you need a specific tool for deployment. Now, when we are talking about deployment of any solution, irrespective of it is machine learning or any other product development or service development applications that are getting developed, right? So ultimately, you'll have to give that software to your end users. Now, when you're trying to do that, there are certain conditions that we will have to keep in mind, right? You might say prerequisites or post-requisites, which are required for us to consider when you're developing any application. All right. And what are those prerequisites? What are those post-requisites? How this particular tool or library, which is called as MLflow, helps. And right, we are basically focusing here, but we will be using Azure platform, Azure Machine Learning Studio, in order to use the resources for ensuring that the application that we are developing, machine learning application, is trying to basically sit on that server, right? So from infrastructure perspective, we are going to use Azure. And using Python, we will be developing the application, the machine learning code, right? For this, we will basically be using Python. And for deployment, when I talk about deployment, we need UI. That UI is web UI is basically Python Flask itself, right? So these are the applications that we are using for deployment. But what is MLflow and how is it used? This is something that we will have to try and understand first. So in our deployment right now, we are trying to look at various scenarios. In our previous sessions of this particular series of videos, we have seen how Kubernetes engine can be utilized for auto deploying, basically deploying and automatically managing the application with respect to the load balancing, right? Then scaling up, scaling down, the data storage perspectives, all those auto management is basically done using Azure Kubernetes service. Right, so this is basically something that we have done in the previous session. Now we can use the same logic here, but we are trying to introduce a new library called MLflow, machine learning flow, which will ensure us to track and maintain the entire machine learning application that we are developing for end user. So this library will ensure that the workflow that we have is monitored. The workflow that we are talking about is managed. So that's the machine learning workflow. So we'll try and understand, and probably for our demonstration, I'll not go through this entire cycle because the steps would be remaining same as part of our previous session. In this particular session, I will try to also introduce, rather than this part, we will try and use Machine Learning Studio. Okay, we can also do this or do this. So it's just the infrastructure and the services which are changing, but ultimately the entire infrastructure is coming from Azure Cloud. So these are two alternate options that we have for deploying your machine learning models. Predominantly in this session, our focus would be on understanding what is MLflow and why it is used. So let us try and understand this particular slide. Whenever we talk about machine learning model development, right, I'm pretty sure majority of you people who are trying to skill yourself into the data science world or machine learning, or you can say data analytics, right? Anything which is related to analytics or data, you probably will be trying to follow certain management methodology, and we basically try to use this. Previously, it used to be crisp DM. I'll write that as well. This was the previous methodology, which was globally practiced, but it has certain flaws, or you can say drawbacks, which did not solve a lot of practical problems for the customers, or for that matter, for the solution users. So there is some improvement in that process, and now we are basically calling this improved process as crisp MLQ. This is standard. I'm pretty sure everybody is aware of crisp MLQ in your data analytics or data related project implementations, if you are coming from that background. Now, what are the things that we have to look at in crisp MLQ, right? From a data science or machine learning implementation perspective, all the newbies, right, who are starting up their journey into data science, who are getting training from various people or institutions or YouTube videos or wherever you are trying to get your knowledge accrued from. The biggest problem that you have is, how do you practically understand this crisp MLQ methodology? If I ask 100 people, I'm pretty sure around 90% of the people will tell me that, hey, this contains 6 phases. This is the general practice that we will have to do. It all starts with understanding the business and data requirements, right? We basically try to understand the characteristics. Then we will say data pre-processing, right? Rather than me writing it, I'll basically take you to that slide, which actually allows you to understand. Rather than slide, I would say, I would take you to the mind map, which is basically going to help you. So all you have to do is click on 360DigiTMG website, which is basically the organization which is providing you this video. And here you see mind map. On the website, you see the mind map. If you click on the mind map, you will see a bunch of these, right, nicely crafted mind maps, isn't it? So under this, we will go to the third mind map, which basically talks about certification program in data science. So if you click on this, you'll get this mind map. And right, we are talking about crisp MLQ methodology. This is basically the crisp MLQ methodology that we have to follow. And it contains 6 phases: business and data understanding, 1A, 1B. This is the first step in the life cycle. We have second step, which talks about data pre-processing. This is where we will do EDA implementation, we do data cleaning, we do feature engineering, we do a lot of reporting, analytics, right? So all these things basically deal with data preparation. Then comes the third step, which is developing the model. When I talk about developing the model, you probably will broadly segregate into unsupervised learning and supervised learning, right? Machine learning primer, supervised learning and unsupervised learning. And then you will also have time series. You probably will also have black box techniques, which are being used nowadays in the space of analytics or machine learning, you can say, right? And when we talk about supervised, further we have classification methods, regression methods, black box methods, ensemble techniques, shallow machine learning models, right? So these are variants, right? And once this development is done, we go to the fourth step, which is the model evaluation. We're not just trying to evaluate the model, but we're also trying to evaluate the solution with respect to the business and the various success criteria that we are defining while we are taking up the project. So whether it is acceptable from accuracy perspective, from logical standpoint, from performance standpoint, right? All those things have to be evaluated. And this is where we'll take the best solution out. Now, once we get the best solution, we go into the model deployment phase. In the model deployment, we are basically again looking into various aspects: hardware requirements, software requirements, the load balancing, the technology stack that customer has, or what kind of deployment we'll have to do. Right? All these things have to be evaluated. And then we will have to try and ensure that the customer starts using the best solution that we have developed. And after this is done, this is the new point with respect to your CRISP MLQ. In CRISP DM, we did not have this monitoring and maintenance, and special emphasis has been given to monitoring and maintenance phase in CRISP MLQ. Now, I'll give you a very simple example if you want to understand why it is so important. Let's say you're purchasing a product, right? It could be any product, maybe let's say a mobile phone. Pretty much everybody has a mobile phone nowadays. So let's say you're purchasing a mobile phone. You probably invest some X dollars, or if you're in India, which this is basically I come from, India, right? So you probably will be looking into some Indian rupees, INR, whatever the currency is. You invest X amount. So let me remove the units and generalize this. So X amount is invested. Now, when you start using your product, the mobile phone, what if there are certain problems that you encounter? Or what if you're not 100% sure on how to use this particular product? Don't you need some guidance? Don't you need some hand holding? Don't you need some support? Isn't it? So we need some kind of a support for using this particular product to its maximum efficiency. Not whatever the X amount you are investing, you probably want to use the product to get the returns. It could be monetary perspective, it could be the features perspective, whatever it is, any product that you purchase, right? So you want to use that. And for that usage, you need some support for various reasons. And obviously, you will not expect the product to work for the eternity. It has its lifetime. So support will have probably some duration, but within respect to that terms and conditions, you will have some kind of a support which you will have to understand, and then you invest on the product if you have the support. Right? Without support, you'll not purchase, isn't it? There are a lot of products which do not come up with warranty, and you generally don't prefer to purchase, isn't it? Now, imagine you are trying to invest in a product. Now, what is that product? You're a customer and you're investing on machine learning model solution. So this is your product in which you're investing. Now, as an end customer, observe this from an end customer perspective, friends. Don't look at this as from a perspective of a developer, a machine learning expert, or a data scientist. Don't look at from that angle. Look at from an end user perspective. If you start thinking from an end user perspective, you will realize that there are a lot of things that you're not doing correctly. Right? Even today, when you develop some application, there will be some of the other cases which you probably will not fit in as per the end user's requirements. Even if you are a very, very experienced person, we generally tend to miss some things. So whatever you try to develop, you always think from an end user perspective, which is something we budding data scientists, I also say myself as a budding data scientist, right? So we budding data scientists don't do. Even after so many years of experience, handling close to 50 to 60 projects, I still realize that I don't cater to all the business requirements. We will tend to miss, that's obvious. But can we start having a practice? Can we start having the habit of always looking at the product development from end user perspective? If you can do that, then you'll realize that this is something that we don't give support, right? And that is exactly what people realized, industry realized, and we had the CRISP DM methodology, which was exactly lacking this aspect. So in order to incorporate the support aspect, we improved the process to include monitoring and maintenance stage. This is nothing but support. Now, when you practically implement a machine learning model, the main aspect of machine learning model is that the model has to continuously work. Now, if you invest on mobile, it's a hardware piece, right? There would be probably upgrades to your operating system or applications, and the design is given in such a way that it is automatically doing that. If you don't have get it upgraded properly, you'll have support who can guide you. Now, from a machine learning model perspective, if the model has to work as expected, it also needs to be updated. But how does model update? A machine learning model is always getting updated based on the data which is being used, right? So this is basically called as continuous training. Now, why we have to look at this aspect is because as the time goes by, any business that we talk about will evolve, will upgrade, will change, will improve. So when it happens, the data will also change based on this upgrades or evolving that the business is happening. So data keeps changing. That's one important point that we need to understand. This is called as the data drift. If you compare this data, which is probably version 1, and this data, which you probably have version 2 or version 3 or version 5, whatever it is, when you're comparing the characteristics of the data, you will be able to understand that there is some kind of a variation. It could be with respect to outliers, it could be with respect to the number of features, new features might have gotten, old features might have been discarded, the distribution of the data might have changed, the range of values that we are having in each column might have changed. So there will be some improvement, right? So there will be drift. Now, if this drift is happening, obviously you will have to ensure that the model that you are trying to give to the end user also should get adjusted accordingly so that it behaves from a business perspective in a consistent way. So when the data was in certain range or certain distribution was followed, certain conditions were displayed, the model was expected to work on that. The same conditions have to be implemented. The expectations perspective, the model is considered to be working at the same level or efficiency, right? Same level of efficiency, even when there is new kind of a data. Now, if I use the same model on new data, then definitely the model will flat, right? It will going to fall flat on its face. So it's going to completely fail flatly. So there should be some improvement in the machine learning model also, right? Now, this is where monitoring comes into the picture. Maintenance means you continuously train it when there is some changes, but in order to detect those changes, you'll have to monitor. Now, in a lot of cases, the business conditions, the data keeps generating every day. We don't have a control. So in such cases, what would you do? How would you monitor? Isn't it? So depending on the business requirements, you are going to try to come up with some strategies or intervals based on your business requirements. You're going to define those intervals to capture the data and then start looking into those batches of data and comparing them, right? And the entire variations that we are looking into have to be monitored, tracked. Now, manually, you cannot do it if you are doing it on multiple machine learning models, on huge amount of data, huge customers. So there will be scaling issues. So practically, you probably may not be able to track everything. This is where automation actually is kicking in to assist the data scientists or machine learning experts to capture all these kind of things, right? So we are talking about tracking of machine learning models. Not just development, not just deployment, but you also want to do tracking. Right? So this is where your MLflow application comes into the picture. The MLflow contains 4 major components. It contains tracking. So this component will record and query the experiments. It basically looks into the code, the data, the configurations, the results, everything is getting recorded so that we will be able to compare them for the changes. This is part of your tracking. Then in order to do this tracking, we need project space. This is the next component that you need to look into. The MLflow projects is basically a component which tries to give you a packaged code. That means it's like a independent software. Your ML code that you are basically trying to develop will be packaged together so that it basically becomes a single software which can be deployed or which can be used by anyone. Everything is coming together. So projects is going to package your data science code, right? And the idea is it basically can be used anywhere by, right, on any systems. So idea is to ensure that reproducibility is brought in, right? So that you can use the same code on different platforms. This is something that we have discussed, right? This is something like your Docker containerization concept. Kubernetes is managing those containers. So we've discussed in our previous sessions on these concepts. Then we have models. These models, this particular component will ensure that the best model which has been packaged here is deployed. So your machine learning model that we are trying to use will get deployed in different environments. Now, because it is a packaged, it can be just taken as a plug and play concept, and just deploy it on your respective environment where you want to bring this. So this MLflow is basically as a framework or an open source library, which allows you to do all of this automatically, right? You don't have to really deal with a lot of things. Automatically, your best model is getting saved, and then for tracking perspective, a lot of metrics and logs are captured. But when you're developing your machine learning models here, you basically have to try and do a lot of experiments, and probably are going to fixate a single model as the best model. And we're talking about continuous training. So there will be upgrades to this model, right? So in order to compare the drift in models, we call them as model drift. This model drift happens because of your data drift. Eventually, data is drifting. So model drift is also something that we will have to evaluate, compare. Right? We need to understand how the model is drifting so that explainability is brought into the picture. To do that, MLflow will record the model that we try to use in its registry. So that means you're trying to develop multiple models. You're experimenting. Probably hyperparameter tuning is happening. So in hyperparameter tuning, you'll be doing probably tuning on different parameters. Each model, each experiment that you're doing with a specific set of parameters will get recorded. So it is basically registering each of this experiment. And why it is registering? So that it can capture all the artifacts of that particular experiment so that it can compare. So it can store, annotate, and manage the models via this model registry by keeping all of these into a centralized repository. Right? So that's basically the MLflow components. We're not going into the details. We'll basically try and implement it to understand what exactly it's happening. So MLflow is an open source Python library, and it's very simple. You just say pip install MLflow. That's all. Okay, but we are not doing it on local machine. right? To actually use the capability of these MLOps related libraries, we need to use the capability of the hardware, and that hardware can be actually utilized appropriately when you go on cloud platforms. Because if you do it on local machine, you have single hardware, you'll have limited processing capacity, limited memory capacity, limited storage capacity, right? So you'll not be able to experiment a lot of things. To actually utilize the true power, you move all these onto cloud platforms. So we are going to try and deploy it on machine learning module.